Alright, so this video I'm going to try and cover the splitting the middle term method. There might be better ways to see this. There probably are. This is just going to be kind of a brief overview of what it is. So first off, I'd like to say, what if I have this ax plus b is one of my linear terms, and then the other linear term is cx plus d. What will this multiply to be? Well, if we use the FOIL method, we'll see that this is going to be a times c x squared plus a times d x, that's the outside terms, and then the inside terms, b times c x plus b times d. Alright, and then we can add the two middle terms together to get AD plus BC, number of x terms, and then I have BD at the end, and of course we still have AC x squared here. Alright, so I'm saying if I were to combine this into a form like this, it would have these quantities of the coefficients would be those quantities if they were A, B, C, and D here. So they're completely arbitrary. They can be whatever they want, or they can be whatever. And mainly my point here is to see that if I were to multiply AC by D by BD like this, I can rearrange these terms to be A times D times B times C. And then these two terms are factors of AC times BD. They're just a different way of organizing the factors, and they also add together to be the middle term. So this is what we're looking at when we're talking about splitting the middle term, is we want to find the sum of two numbers such that they multiply together to be the coefficient of the first term times the coefficient of the last term. Or in other words, the multiple of these two terms has a factor such that the sum is, or it has factors. Well, let's see what I mean by that. Sorry, that's kind of wordy and confusing. It's so wordy I can't even say it. But let's do an example, and I'll just leave this part up here so we can kind of see what's going on. I'll just do backward examples, since I don't really have any of these planned out. But I'll just pick all of my favorite prime numbers. Okay, and so this is going to be, well, to see how it happens, let's do the distribution that I was talking about. In other words, I'll distribute this term into each one of those terms. So it's going to be 3x plus 1 times 5x, and then plus 3x plus 1 times 3. And then from there, I distribute into 5x, so I have 15x squared plus 5x plus, and then I distribute the 3 in, so I have 9x, and then plus 3. Okay, and then I would combine those terms, and I would have 15x squared plus 14x plus 3. So I could go ahead and do that too. 14x. Alright, so the main point here is that 15 and 3 represent AC and BD there. So I could say, for here, I'll just do like AC times BD is what 15 times 3 is. That's similar. And so 15 times 3 is 45. And I'm looking for factors of 45 that will give me what AD plus BC is. Okay, the factors of 45, so we just have to run through them all in our head. We can do 5 and 9. 5 and 9. Yeah, 5 and 9. Those are the factors of 45. And those just so happen to add up to be 45. So if we can see how this happens backwards, we split the middle term, and then we see that we can factor out a common term, mainly 3x plus 1, out of the first two terms here and the last two terms there. So this just requires a lot of examples to go through. This was just kind of in a generalized form. The thing I wanted to recognize here is that if I multiply that coefficient by that number, that it's going to be A, B, C, D pretty much, and I can factor A, B, C, D as AD plus BC. So I can always know that if it takes this form here, that this middle term here can be split up into two factors that multiply to be the product of these two numbers here. So I guess I'll just do an example really quick just to make sure that we're on the same page. If I really just kind of writing down some various examples, so I'll just do this one. Let's see, 15x squared plus 19x plus 6. Okay, so this is a pretty easy example when you see it, because we're multiplying 15 by 6, and that's going to be 90. And I'm saying 90. What numbers can I split that? What factors of 90 sum together to give me 19? 9 and 10. So it's going to be 15x squared plus 10x plus 9x plus 6. And then from here, we see, you know you're on the right step, or you have these numbers in the right position if the ratio of this number to this number is the same as the ratio of this number to this number. In other words, 5 to 10 is the same as 9 to 6. It is. So that means we can factor out a common factor here. So I'm going to factor out a 5x here. This is 5x is the common factor of these two first terms. So it's going to be 5x times 3x plus 2 plus, and the common factor here is 3. So plus 3 times 3x plus 2. And now we see the common factor between these first two terms and those last two terms is actually 3x plus 2. So I can factor that out. 3x plus 2. And then when I factor 3x plus 2 out of that term, I get a 5x. And when I factor 3x plus 2 out of that term, I get 3. So this is the two. So if we start from here, I can represent this quadratic in a form of a product of these two linear terms. Is what I wanted to show. So maybe I'll do one more quick example before I end the video. I want to do something with a negative number. That way we can see that it also works with negative numbers. Let's see. I'll do two more examples. So x squared plus x minus 2. This is a pretty simple one. I have negative 2 multiplied by 1 is negative 2. I say, what are the factors of negative 2 that will give me positive 1? Well, 2 and negative 1. Those sum together to give me positive 1, and they are factors of negative 2. So then I can split the middle term like this, x squared plus 2x minus x minus 2. And now remember, I'm looking at the ratio of the first coefficient to this number, and that's 1 to 2, and then the ratio of the coefficient here to that number, negative 1 to negative 2. So 1 to 2 is the same as negative 1 to negative 2, so I'm on the right track. I factor out an x here, so I get x plus 2 Then I can factor out a -1 here, so it's just negative x plus 2. And then I can factor out the x plus 2 term, and I get x plus 2 times x. So I factored out the x plus 2, and I'm left with an x there and a -1 there. Okay, last example for this video, because I don't want to have my videos go too long, because honestly, when I'm watching videos, I never watch videos that are much longer than 10 minutes. Just because, you know, attention span and all that. But okay, so here we have 21 times -2 is going to be -42. And I'm looking for the factors of -42 that will sum together to be 11. So I know since this is a negative, one of those factors is going to be a negative number. So actually what I'm looking for is a difference of two numbers that give me, that multiply together to be 42. So those two numbers are going to be 14 and 3, and one of them has to be negative. And I know I want a positive 11, so I know the 14 is going to have to be positive. So the difference between 14 and 3 is 11, and I can multiply 14 and 3 to be 42, or negative 42. 14 and negative 3. And so then I want to put these in the right order so that 21 to one of those numbers is the same as the other number to 2, the ratio rather. So I know 21 to 14 is the same as 3 to 2, so I'll go ahead and put the 14 first. So 21x squared plus 14x minus 3x. So that 11x is just being represented now as 14x minus 3x minus 2. Okay, and then I can factor out a 7x here, and I get 3x plus 2. I can factor out a -1 here, 3x plus 2. So I have the same term in parentheses here. Now I'm on the right track, and I can just factor out that 3x plus 2. And I'm left with 7x minus 1. Alright, I'm going to go ahead and end the video here because I feel like this is a good spot to end. But in the next videos, I'm going to cover, I think, applications and completing the square of quadratics, and maybe eventually I'll get to like the shape of a quadratic is a parabola. That's important. I'll definitely talk a little bit about that, about parabolas and conic sections later.